Welcome to the University of New Hampshire's Interoperability Lab. Today we're going to be looking at and we'll be seeing a demonstration of the Broadband Forum's CloudCO 2022. With us is Lincoln Lavoie. He's going to be leading us on that demonstration. Lincoln?
Welcome, Ken.
Thank
Glad
you.
to have you here.
Well, let's check this out. With the increasing adoption of software-defined access networks, the separation of control and data planes is driving an increasing need for the virtualization and disaggregation of operators' networks and functions. Today, I'm joined by Ken Ko, Managing Director of the BBF, and Lincoln Lavoie of the University of New Hampshire Interoperability Lab, who is also the BBF Technical Chair. Ken, please give us the goal of CloudCO and the drivers and use case for this year's demonstration.
Well, first of all, CloudCO is really all about being able to migrate from the traditional legacy network based on a large number of nodal network elements to the much more open, much more virtualized CloudCO network based on open standards and distributed software. This migration allows network operators to take a step-by-step approach, which lets them move and update network elements on their own pace and in the order that works best for them, while at the same time allowing them to amortize and continue to make use of their existing network investments. First off, we really should talk about the drivers behind CloudCO. On the one hand, there are direct benefits for the operator. They get to move to a much more agile network. CloudCO fosters a multi-vendor ecosystem that's based on the definitions in our standards APIs. CloudCO enables automation of network operations. All of these things combine together to reduce CapEx and OpEx for the network operator. But on the other hand, it also provides the opportunity to greatly enhance the service experience for the broadband consumer. And to learn more about this, please take a look at the video, The Importance of Broadband Forum CloudCO, and this provides a number of network operator perspectives.
Lincoln, what is being shown in this year's demonstration?
This year's demo is really going to hone in on two specific use cases. First, zero-touch provisioning, and secondary, network monitoring and maintenance through AIM or Automated Intelligent Management. Within the video and demo, we're really going to hone in on the specific building blocks and software subsystems that make up the demo, and those blocks being provided by the various vendors and participants of the demo, and all of those pieces coming together to really show a multi-vendor implementation of the BBF solutions and open standards being produced. Also, we're going to really show how virtualization brings benefit to the network and disaggregation enables you to split up the components in the control plane, breaking apart physical devices and physical pieces into the software subsystems, enabling orchestration and SDN-driven solutions into the complete and total network. Those components then can be located anywhere throughout the network, as well as hosted in cloud provider systems in the form of software systems that may be deployed automatically or scaled automatically as necessary. Lastly, one key component that we do want to highlight is the inclusion of some of the open source projects from the Broadband Forum's Open Broadband initiative, such as the Open Broadband Access Abstraction Framework, or OBBAA. One key thing that I'd like to also really emphasize during this talk is this is truly incorporating work from across all of the Broadband Forum's different work areas, including our SDN NFV areas, ATA, our Common Yang, as well as our bus work area, making it a true demo spanning the entire breadth of the forum's work.
So from an operator's perspective, what are the key dimensions you want to highlight?
Well, at the highest level, there are two key dimensions that we're demonstrating this year. The first dimension being network virtualization and disaggregation. We've got multi-vendor contributions with multiple OLTs, multiple ONUs, and traditional and disaggregated BNGs, as well as associated management and orchestration solutions. What this really shows is how vendor-branded solutions, gray box solutions, white box solutions can all work together with the associated end-to-end orchestration and also single access domain orchestrators. Now, the second dimension is all about zero-touch provisioning and service setup. With this dimension, you will see the network completely in control of service setup. It takes care of user profiles and user service setup without any need for actions on the part of the user or on the part of the operator. Similarly, once you have the user services set up, any changes required in those services are handled dynamically by the network. Once again, no need to get the operator directly involved with any manual actions. CloudCO is all about enabling virtualization and disaggregation in the network. It is also all about the ability to migrate and to get from that legacy network to that highly virtualized, highly disaggregated network, while at the same time allowing the operator to do that migration in a way that preserves their existing investment.
What is new in this year's demonstration?
So if we take those couple of use cases that we talked about and we really drill down into them a little bit more depth, we can start to see that there's 4 or 5 kind of key areas that we'll start to expand upon. Specifically, we have the disaggregation of the hardware into hardware components as well as the software components that may be hosted in the cloud environment. That can happen both on the access network as well as in the edge network with things like the BNG. We have the automated intelligent management framework, which is allowing the network to make adjustments to itself based on input and monitoring happening from the network within the systems. That monitoring is actually taking place from another part of the Broadband Forum project's QED, or Quality Experience Delivered, where real-time monitoring is taking place throughout the demonstration, and that is actually triggering an input back into that automated intelligent management systems. Lastly, some of the decision making coming out of that management system can impact things like subscriber session steering, allowing us to reroute traffic dynamically through the network as necessary to deal with congestion or other such events. All of this is made possible through things like the SDN controllers that on the Access Edge side of things, we're actually managing 5 OLTs from various vendors through common interfaces defined by the Broadband Forum, as well as incorporating ONF's Volta solution as well, as previously mentioned by Ken. From there, we actually then move into the Edge network where we have the disaggregated BNG, separating out the control plane from the user plane based on the Broadband Forum's 459 work that describes those interfaces as well as those mechanisms. That relates directly then back to that subscriber session steering I just mentioned a minute ago in terms of being able to reroute traffic dynamically through the network. So as we drill down through the demo, we'll actually move through and actually see each of these pieces in action, starting with the zero-touch provisioning use case where we'll actually bring the initial subscribers online.
You mentioned multi-vendor. What does that entail in this demonstration?
CloudCO framework is based on Broadband Forum standards, and those standards are available to any vendor in the industry. And what that means to the operator is that they can incorporate solutions from any vendor, so long as that vendor is compliant with the standards, and have a good level of confidence that those solutions will work together and will provide what the operator is expecting to have in their network. Speaking of vendors, I want to give a big thank you to the vendors who participated in this year's demo, along with network operators and consultancy companies. We had a lot of participation this year, and I should also mention that we worked together with ONF in order to incorporate their Volta solution into the CloudCO demo this year, and thank you for that. Finally, a big thank you to the sponsors for this year's demo. We're including Altice Labs, Deutsche Telekom, Hewlett-Packard Enterprises, Juniper, Nokia, Radisys, Reply, and Zytel. Without these sponsors, we wouldn't have been able to do this demo this year.
I would now like to give the floor to Tom Van Kanjium from Nokia, who has been coordinating the preparation of the demo since spring of this year, and who will now provide an introduction to the demo.
Hello, my name is Tom Van Kanjium and I'm with Nokia. This year I had the privilege to coordinate the preparation of the Broadband Forum CloudCO demonstration for the Network X event in Amsterdam. In the previous part of this video, CloudCO explained the drivers behind the Broadband Forum or BBF CloudCO concept, and also this year we wanted to articulate this in the demo by showing 2 use cases. One use case focusing on the zero-touch, high-speed internet access service setup in a multi-vendor context, leveraging network function virtualization and disaggregation. And with a second use case focusing on zero-touch service assurance based on performance monitoring, leveraging network probes combined with traffic steering. Here in this chart, you can see an overview of all the building blocks and vendors involved in this year's BBF CloudCO demo. At the highest level, we see the service management platform CloudCO Domain Orchestrator, which is implemented this year by HPE. The CloudCO DO interacts with several network management platforms that can all be hosted on a Kubernetes cloud platform. Perhaps the most important one here is the Altiplano solution of Nokia, acting as the access management and control platform that manages in this demo the PON OLTs and ONTs from up to 5 different vendors, either directly, either through the BBF open source BAA software, and, this is new this year, via the Volta core of Open Network Foundation or ONF. The other network component I want to highlight here in this chart in the demo setup is a Broadband Network Gateway or BNG. And also here, virtualization and disaggregation has kicked in. BNG control plane and user plane are now separate entities, and where next to control plane, even user plane can be virtualized. Furthermore, we also have a virtualized user plane selection function or UPSF doing traffic steering. In this demo, we will use Juniper and BISDN BNGs, whereas Vodafone will provide the UPSF. Finally, I want to highlight that we also have QED probes from Altsys that measure delay performance between the residential gateway and the network. The residential gateway, as shown in the bottom left corner of this chart, is a Nokia beacon, which hosts this QED probe, as well as a Wi-Fi monitoring and Wi-Fi service optimization application from the company Domos. These apps, along with the beacon, are managed with TR369 from the Nokia HDM, which itself is reporting to the AIM controller hosted in the HP CloudCO DO. This makes the circle round, as this is where we started our overview. It's now my pleasure to give the floor to Lincoln Lavoie, who will provide much more details and guide you through the different use cases.
So now we're going to talk about zero-touch provisioning and its use case. Lincoln, why don't you take us through that?
Awesome. Thank you, Ken. So before we really get into the use case, let me first start by saying it takes a lot of effort every year within the demos to build this up. And I really want to thank the participants and all the individuals that were committed to making this demo a success. It really does show the level of vibrant participation within the forum and the community as we go through working to build these systems and establish the demo as well as the level of cooperation necessary to really bring this to fruition. So it's been my pleasure to work alongside this team to really make that happen. So Ken, over to you as you kind of set us up and explain a little bit about what Zero Touch is all about, and then we'll go into the lab and actually take a look at it running in real life.
Zero-touch service creation has been a theme throughout previous Broadband Forum demonstrations. This year, the Broadband Forum wants to highlight the ease through which CloudCO architecture based on SDN, NFV, open source, cloud-native implementation, and standardized APIs enable the multi-vendor operation in the ISP network. This is exemplified in this year's demo by having different ways in which a CloudCO environment leverages virtualization and disaggregation, where certain control and management functions are extracted from PNFs and hosted as VNF CNF in a cloud-native environment. Lincoln, please tell us about it.
As we can see from the diagram of the network architecture, the CloudCO demonstration is constructed from a number of functional blocks. The architectural view maps quite nicely to the real implementation, where the control and management functions on both the access and edge networks, such as the DHCP relay functions, BNG control planes, and user plane selection function, and even the larger cloud components, such as the SDN controllers and the domain orchestrator, are hosted in a common cloud environment, in this case, a Kubernetes cluster. Each of these network functions then expose a standardized interface defined by the Broadband Forum's open specification. It's through the common understanding of these open interfaces that the team was able to quickly integrate each of the demo's components, virtual or physical, to achieve the final working product that we're showing today.
In this year's demo, we will also show disaggregation and virtualization at the edge. Sandeep Patel of Juniper will discuss their first-time involvement in the CloudCO demonstration. In this demonstration, Juniper and also BISDN are bringing together BNG, distributed BNG, and also BNG control plane and user plane separation from a TR-459 and CUPS perspective, enabling zero-touch provisioning and service delivery.
Thanks very much for including Juniper in this year's CloudCO demonstration. Juniper has been heavily involved in BBF standards efforts for some time. We're committed to BNG CUPS standards development, and Juniper engineers provide significant contributions to the BNG CUPS and wireless wireline convergence standards development efforts as workstream leads and/or editors. As the industry moves towards a unified cloud-based control model for CSP networks, Juniper will continue to help shape these transformative standards and participate in cooperative efforts like this to demonstrate the possibilities. The reason we've made this investment was because BNG CUPS offers architectural alternatives to traditional BNG implementations to resolve some business challenges that are top of mind to many CSPs today. CSPs would like to have flexibility to distribute user planes closer to subscribers. To deliver the quality of experience customers expect, CSPs would like to service more applications locally in the Cloud Metro network. CSPs want to further simplify operations. Traditional broadband networks rely on centralized architectures using vertically integrated routing platforms with large internal fabrics to serve hundreds and thousands of subscribers. Some operators are pursuing BNG architectural alternatives that are more modular with simplified device configurations, software releases, and planned and unplanned maintenance. CSPs need to align network investments with business growth. In the past, CSPs have met growing subscriber demand by scaling up, swapping out centralized chassis with bigger, more powerful platforms. Today, CSPs would like the option to scale out, to expand some markets and services incrementally by adding smaller, more cost-effective platforms as needed. This would have the benefit of tying CapEx more closely to demand. For CSPs, seeing network costs and complexity climb, the question isn't whether to consider these new architectures, it's when they'll have the option to start using them. Juniper Networks is committed to meeting these customer objectives by offering the Juniper Broadband Network Gateway control and user plane separation BNG CUPS solution that's central to this demonstration in the control and user plane functionality. Craig, thanks very much for including Juniper in the demonstration this year. We're looking forward to working with the BBWF as BNG CUPS and WWC standards continue to evolve to show the possibilities. Thank you.
All right, welcome, and thank you for rejoining me here in the laboratory where we're going to walk through the zero-touch provisioning of the CloudCO demo. So as part of this process, the first order of business would actually be the ISP or the service provider actually making a business entry in their OSS/BSS system for the subscriber order. That you're going to view here on the screen as we walk through that process. Next, they're going to enter in all of that order information for the subscriber information. They'd have information about the ONT device that they're shipping to the subscriber, as well as the kit there where the subscriber is located in the world, neighborhood, etc. That's going to really kick off the whole system and series of events here. That order is going to go into the CloudCO domain orchestrator. That domain orchestrator is going to start communicating with the access controllers on the access side as well as the edge side, so the Nokia Altiplano system. That's going to start preparing the network for that eventual subscriber attachment event. Similarly, on the edge SDN controller side, that's going to start creating the subscriber accounts in the AAA services. That's going to start controlling and setting up the BNG and the user plane selection function, which will determine which BNG forwarding plane is selected and allocated to the subscriber. And all of that's going to actually eventually trigger there on the subscriber attachment event that we'll see in just a minute here when we connect the actual ONT equipment to that network. So obviously in the real world at this point, there would have been an actual physical event occurring with the kit being shipped to the subscriber and getting installed and attached to the network once it arrives at their premises. Here in the lab, we obviously kind of have that constraint. So I've got the ONT right here. We're going to work through and actually get that connected to the network. And then we're going to be able to watch the provisioning occur automatically through the SDN controllers and the domain orchestrator controlling those series of events. So I'm going to connect the fiber here, and we're going to watch the ONT come online. So the PON's connected up. And then we're going to actually be able to see the attachment events flow through. We should see on the domain orchestrator screen in just a minute the service become active and everything become healthy. What's happening in the background at this point is we're actually going to see a DHCP event occur from the RG device. That's going to run through the access network and trigger up through to the BNG. The BNG is going to obviously authenticate that user, make sure that that session is valid and should be attaching to the network. And then it's also going to reach out and query the user plane selection function to determine which of the BNG forwarding planes should be allocated to this specific subscriber. So let's watch this series of events happen in the network. So as you can see, the initial attachment event has occurred here in the domain orchestrator GUI. The network connection is established here first with 411. The selection plane function is going to actually occur, and we're going to see that network connection is going to move over to 412 as the selection function is allocating this specific subscriber to BNG forwarding plane number 2. All right, so now that we've shown that the Nokia RG was able to come online, communicating with Altiplano, that access controller, through the Broadband Forum's open BAA access abstraction layer. Now we're going to change gears a little bit. So back to the domain orchestrator screen here, we can see that we have a number of other pending orders. Specifically, we're going to hone in here on the Volta Zyzel order, where that OLT is actually under the ONF Volta's controller. And we're going to see the same attachment events occur as that subscriber also comes online. In just a minute, we should see that initial attachment event, followed by that same subscriber steering occurrence as the network connection gets allocated to the forwarding plane that's being used for that subscriber. So here we are, we've seen that subscriber event occur, where we had the attachment event, the subscriber selection steering function happened, and the network connection then got allocated to the final subscriber forwarding plane there with that BNG that's being used for that specific subscriber. And now that service is up and healthy and attached. Also, you can see here from the screen that we did have another OLT with the Volta Radisys OLT that was previously online. So with any real subscriber or operator event, there are many, many subscribers in the system all being managed. And you can see that that system was previously online, again, with the forwarding plane selection happening to select the correct Juniper BNG that's being used as part of that process. Again, everything that we're showing here today in the demo is really honing in on some of the disaggregated both access nodes as well as the disaggregated edge or core network with respect to the BNGs based on the Broadband Forum's TR-459 work as well as the subscriber session steering work in 474. So now that we've seen our attachment events for the zero-touch provisioning and all the systems are online and connected, we can see here that we're looking at the domain orchestrator system that's sitting at kind of the top level of the network here. So that system is communicating directly to the access controller as well as the edge controller, the access controller being the Nokia Altiplano system. That system is then communicating to the OLTs through BAA or through Volta. So that's where we kind of see our first distinction here looking through this list of OLTs, where we have the Nokia OLT communicating through BAA. We have the Zyzel and Radisys as well as one of the Altice Labs OLTs communicating through the Volta platform coming from ONF. And then the other Altice communicating through BAA. And so that's one of the really key points here in the demo is that we're actually starting to see the unification between the Volta platform coming from ONF along with the BBF work as well, all coming into a unified system that can become available through CloudCO. Similarly, if we move here over to the OMCI, we can see that there are a couple of different OMCI implementations that are being utilized as well. So we have the embedded OMCI implementation, where the OMCI stack is part of the OLT hardware. We have the open OMCI implementation, which is coming from the Volta systems. And then lastly, we have the virtual OMCI coming from the Broadband Forum, where the OMCI stack's actually disaggregated and being hosted in the cloud environment as well. Similarly, if you remember back from the network diagram that we showed earlier in the video, the Altice Labs OLT is also using a disaggregated DHCP relay function as well that is also being hosted as a cloud native function hosted inside the cloud resources here in the lab.
Thank you, Lincoln, for this very interesting demo, highlighting the disaggregation, virtualization, and multi-vendor capabilities in a CloudCO environment, and realizing a zero-touch, high-speed internet access service fulfillment. In this year's CloudCO demo, We also want to draw attention to the assurance process, where there's a high need by the service providers for automation, ultimately leading to a zero touch in the assurance domain as well. The BBF previously released the AIM framework, AIM being the acronym of Automated Intelligent Management, defined in TR 436 with specification work still ongoing in BBF WT-486. In this part of the demo, we will now showcase a specific implementation of the BBF AIM framework, where three capabilities play a crucial role. The first capability is the presence of the network and residential gateway embedded probes from the company OutSys. These allow measurement of network and delay performance between the subscriber premise and any location in the ISP's network. The second capability is from the company Domos. They have an application in the residential Wi-Fi gateway that can measure Wi-Fi performance and optimize the user experience for a specific service flow in the case of Wi-Fi congestion. The third function emphasized in the same demo is the traffic steering from one BNG user plane to another user plane, triggered by network congestion detection that is signaled by the OutSys network probes to the AIM controller. Now back to Lincoln, who will discuss the AIM demos.
So now we have the subscriber activated onto the network. The next critical piece that we obviously have from a service provider's perspective is the operations and maintenance of that network. And one of the key points to that is maintaining the health and availability of the subscriber's Wi-Fi. So here we're actually going to demonstrate how AIM can monitor the Wi-Fi system in collaboration with Domos and their application to verify and maintain the latency of the applications over that network. So as part of the system here, we have the HPE controller, which includes the component of the Wi-Fi AIM monitoring system. And in the lab, we're actually going to impair the Wi-Fi and then let the controller react to that. So through the Domos app, it's monitoring the Wi-Fi system. It can see that the Wi-Fi goes unhealthy and then actually is going to make corrections to the Wi-Fi to bring it back into a healthy state. So as we can see, now we have the Wi-Fi and the latency gone back into a healthy state with the changes that the AIM system has made to the application and the Wi-Fi environment. Now that we've seen a Wi-Fi demonstration of how AIM is able to apply a closed loop control to the system, we're going to look further into the network. Obviously, it's not only Wi-Fi that can cause degradations to the consumer's quality of experience, but also sometimes things can change inside the network. What we have deployed here in our demo network is the OutSys QED analyzer, along with, again, the AIM controller located as a component of the CloudCO domain orchestrator. And that system is continuously monitoring the health of the network. So within the lab network, we've injected some latency and some congestion into one of the forwarding planes. And as we can see, through the TR-459 and the disaggregated BNG, there's subscriber resiliency baked into the specification. Now, what's going to actually happen is the AIM system and the OutSys QED monitor and analyzer is going to detect that there is degradation in the network. And the subscriber session steering functions are going to be used to move the subscriber shard to a non-congested forwarding plane or alternate BNG. Again, that's a resilient subscriber operation as it's a hot move and the subscriber never actually loses connectivity to the network. And so we can see that that actually was able through the closed loop automation and the AIM controller to reset the user experience back to meet the expectations.
Thanks again, Lincoln, for leading us through today's demonstration.
Very welcome, Ken. Happy to have you.
And thank you all who participated in the demonstration, Broadband Forum members near and far. We hope you enjoyed this video and found it interesting and informative. If you want to know more about CloudCO and the ongoing work in the Broadband Forum, please get in touch with us at the link below. Thank you for watching.